Okay, so today we're going to be looking at section 4.3, operations on rational expressions. Since rational expressions are basically fractions, this is just a recap of how to do fractions just at the level of the rational expression. So I'm going to walk you through some examples that are already produced here so that you can see them and kind of use them as a guide for your future work. So the first thing you want to be able to do is you want to be able to simplify, or otherwise known as reducing, a fraction. So how do I go about doing that? You're going to factor the numerator and the denominator completely, and then you're going to reduce any common factors. So once I factor the numerator and the denominator, if there is a common factor, I'm going to reduce that out. So C divided by C is 1, and so then I end up with just A over B. So here's how it looks, and this is journal problem number 1, showing you which one I'm doing in the journal. I'll show you the journal list that we have here to work off of. So you can see that I have a bunch of problems here that we can use as examples to work through in our work after this video. So here's the problem number 1. We start with this expression right here. Then we want to factor it out. So again, make sure you go review factoring techniques if you do not remember how to factor completely. There's a video in your important information. So the first thing you do is look for a common factor. In this case, 2n. You're left with this, and the bottom has a 3. Then I take these trinomials right here, and we're going to look to see if they can factor even more as a product of binomials, and indeed they can. Once I factored everything completely, I look at this and I see, is there anything common in the numerator and in the denominator? And I notice, yes, there's an n minus 6 in both, so that I can reduce those out. And what is left over is my final reduced form. So that's what you do. Make sure you factor everything completely, and then look for common factors to reduce out. All right, the next thing we're going to look at is multiplying. So how do I multiply fractions, basically? Well, in this case, we're going to look again, factor completely, okay? Because if I can factor everything completely and I can reduce some things, then I'm going to do it ahead of time before I multiply. So that's one of the reasons why we do factoring completely. You'll see that's the common theme through all of these works that we're going to be doing. Once I have factored completely, then I can multiply the numerators together and then the denominators together. So tops to top, bottom to bottom. And then I look, okay, is there anything common? And can I reduce anything? And there's a C, that a factor that is common to the top and the bottom. So those reduce out, and I'm left with my final answer. So here's an example that we did. So here we're multiplying these two expressions. So we're going to factor everything completely. So I go off over here and I start factoring the numerators, denominators, and everything, looking for common factors and all that stuff. And then I notice, hey, I can multiply across and then reduce, or I can simply just start reducing now. I notice that there's an x minus 4 here and here, so these will reduce out. But in addition to that, I notice that there's an x minus 4 here and one on top over here. So as long as there's a factor on top and one on the bottom, it can reduce out. Because remember, to multiply, I'm just multiplying everything on top and then divided by everything on the bottom. So literally, I can just think of this as one big fraction line right here. And so these are all on top, and so they reduce those two things on the bottom. I have a 10 here and a 20 here, so those reduce and becomes a 2 on top. A 2 and a 4 here, so those reduce with a 2 on the bottom. So the 2 on the bottom and the 2 on the top can reduce out, and this is what I'm left with right here. So take your time, go through this real quickly and see that you can reduce all these things out to get to this final answer that's down here. How do I divide? How do I divide? In division, we don't really divide. What we do is we flip the second fraction and we change it to a multiplication problem. Okay? So to divide by a fraction is to multiply by its reciprocal. So once I've done that, and I've rewritten it as a product, then I'm going to follow the steps for multiplication up here. I'm going to factor completely and then reduce and multiply straight across and all that stuff. It is important that you do this first before you even factor anything, because a lot of times people will start factoring stuff and then they forget that they haven't flipped it yet and they make mistakes. So rewrite it as a product first, then factor everything completely, follow exactly these 3 steps up here for multiplying. So here's an example. So the first thing I do is I look at this and I say, oh, it's a division, so I'm going to rewrite it, flipping the second fraction as a product. Okay? And then we're going to go through the process for multiplying, which I have over here. So once I have that, then I can go through and I can factor every one of these things completely. Then I can look for common factors, and you can see, just go through them yourself and see how many you can find. Make sure you can see all of them. So that's common. Those are common. I have this R and that R drop out. This 3 and 6 become a 2. There's a 2 here and here, so that becomes a 2 over 9. And so then you can see how I have a 4 on top. So the 2 here with the 2 that's left over here, the R squared, and the 9. And that's how that comes about. Again, make sure you walk through this yourself so that you understand how all the reductions occur. Those are your main ones that we all know how to do, fine and dandy. Now we're going to do the adding and subtracting ones. This one causes some concerns for people. A little bit more involved. Not this one, because here we already have like denominators. Adding and subtracting we do at the same time, because it doesn't matter which one it is. You just simply make sure that you do it, either the addition or the subtraction. I do want to point out a couple things real quick here, just to help you with any sign issues that may occur. If I have the like denominator, the bottom numbers are the same. You simply add or subtract the numerators, and you keep the denominator. Once you get done with that, you simplify everything out and then reduce if possible. You'll notice right here that I have a parenthesis right here. This is important. So this is the one little rule I think you need to keep in mind, okay? In fact, we're going to actually add it to our work over here at this stage and put it as a little addendum here, okay? That if the expression in the numerator and or the denominator is more than one term, put it in parentheses. There's an added note. This causes a lot of issues for people who don't do this. They always end up with a sign error. This, even though it doesn't have it, all numerators and denominators, even though you do not see them, are automatically in parentheses. All of them. They're automatically in parentheses, even though you don't see them. So when I combine fractions, remember it's the numerator over here minus the numerator on the second one in parentheses. If you don't do this, then you usually end up with the sign error on that +1 and get the wrong answer. Okay, so that is very important to remember that concept right there. Okay, now the fun one. What happens when the denominators are not the same? Well, when the denominators are not the same, we need to find what's called the least common denominator. Hopefully you remember this from your days back in elementary school. All of it's exactly the same. I'm going to show you a couple things about finding the least common denominator and what it actually is. So here we go. I'll show you the methods in a moment. The least common denominator, this is literally is the least common multiple of the denominators. That's what it is. It is the smallest number that every denominator will divide into evenly. So when we look for the least common multiple, we're literally doing the process for the least common denominator too. So here it is. What is the least common multiple for 12 and 14? What is the smallest number that both 12 and 14 will divide into? That's what we're looking for. In grade school, you probably did it somewhere, something similar to this. You had a little list here, here's 12, and you did your multiplication tables, and you multiplied every number out as far as you can go for a while. And then you went down to 14, and you did the multiplication table for that. 14 times 1 times 2 times 3 times 4 times 5 times 6 and so forth. And when you got to a number that was in both lists, That's the least common multiple. Okay? When I have numbers, this is easy to do. Okay? This is an easy way to do this. If you have numbers, you just simply do that process and it works out. And you get a least common multiple of 84. So if these were denominators, then I would be changing the fractions to this denominator. Okay? And that's what I would be doing. But we're going a little bit beyond that. We need to be able to incorporate a lot of different things. And so you may have seen this technique also, and later on, maybe junior high or high school. This is called the prime factorization technique. And literally every number can be written as a product of prime numbers. And so what you're doing is you're going to rewrite every number as a product of prime numbers. Remember, prime numbers are numbers that are divisible by only one and itself. Like, so you start off with 12. You say, okay, give me two numbers, multiply, give me 12. And then you look at 2 here, and 2 is a prime number. Because the only way I can get 2 is by 1 times 2. That makes it prime. 6 is not a prime, which means there's 2 numbers that multiply and give me 6, 2 and 3, and both of which are also prime numbers. So the prime factorization for 12 is 2 squared times 3. We do the same thing for 14. We get 2 times 7, both of which are prime numbers. And so we write it out. So when you write it in prime factored form, it has to be in exponential format. So you got to have it in exponents. You can't write this one as 2 times 2 times 3. It has to be 2 squared. Okay? So this is the technique we're going to do. We're just going to do an extension of this technique because we're going to have expressions, polynomial expressions and stuff that we have to deal with. So we write the prime factorization. Then we're getting ready to write our answer. We're going to write down every different base number from both lists. So the base numbers are the big numbers here. So there's a 2, a 3, a 2, and a 7. We don't repeat. We only write it one time. So even though both of these have a 2 in it, we only write the 2 one time. So the big numbers down here are 2, 3, and 7. The last part right here is we write the largest exponent that appears on each of the numbers I just wrote in the entire list all up in here. So we start with the base number 2, and we see that the biggest exponent is 2. This has a 2 squared. This is a 2 to the 1. So the biggest exponent is 2. So we put a 2 on it. For the 3 and the 7, there's only 1s. And so because of that, that is my least common multiple. I just need to multiply it out to get my answer. And again, it's 84. So that's another way to get 84. And because we have expressions and stuff and not just numbers, we're going to have to do something similar to this technique. Okay? And so I'm going to show you how to do that here in just a minute. We will be using the factorization method to find the least common denominator for rational expressions, although you can use the grade school method, okay, for the number part of your LCD. So if I have numbers involved, okay, I don't need to do the prime factorization of the number, although you can. You can actually just do this technique right here, which is, a lot of people can do this very quickly, almost in their head sometimes. And so there's no reason to do this. All right, so let's look at another example here. And here we go. Here's our example. Find the least common multiple for x squared minus 4, x squared plus x minus 6, and x squared plus 4x plus 4. So you see it's a little bit more challenging. These are polynomials here, and we cannot use the number method. We have to use the factorization method. So the first thing I'm going to do is I'm going to factor everything completely. I usually do this on the side over here. I'm going to factor it completely, and I'm going to put it into exponent form. So the first one, x squared minus 4, that's the difference of 2 squares, so I write it as a factored form. This expression right here, I factored that, I get that. And then the last one over here, I get that, which is the same quantity twice, so I have to put it as x plus 2 squared. You have to have the exponential in exponent format. Okay, so now that I have everything factored, I'm going to write down every base number that appears, but only once. So in this entire factored list over here, I see x plus 2s, x minus 2s. There's an x plus 3. I already did that one. I already did that one. So that's how I start. x plus 2, x minus 2, x plus 3. Those are all the three different base number expressions. Then I go back in my entire list, because I put everything in exponential form, and find the highest exponent on each of these expressions, and this one had a square. That is my least common multiple. So if these were denominators, this would be the least common denominator. You don't need to remultiply it out, leave it already in factored form, because it makes it easier for the next step. So that's how we do it. If there was a number involved, then if like this had a 2 out in front and a 3 and stuff like that, then I would do the, find the least common multiple for just the numbers itself. So I would do the numbers, then I would do the expressions. Okay? So how do I add and subtract unlike denominators? I have to find the least common denominator. Then I'm going to change each fraction so that it has that denominator. Then I'm going to add and subtract, combining like terms, simplifying, all that good stuff, and reducing if it is possible. This is what we're going to do. So here we go. Let's go do it. So here's my two fractions. There's my two denominators. I go off to the side. I write them down in factored form. It was pretty straightforward. So this right here, factored right there. And then this one is right there. And then I look at this and say, okay, what are all the different base numbers? There's an n plus 1. There's a 5. Don't forget the number. And there's an n minus 1. Nothing was repeated or anything like that. There's no exponents on anything. So that is my least common denominator right there. Okay? Keep it in factored form. I'm going to change each of these fractions so that it has that denominator. Okay? This already had a 6n on top. I had that on the bottom. I want that to be on the bottom. So to get this on the bottom, I have to multiply the bottom by 5n minus 1. That means I need to multiply the top by 5 times n minus 1. Remember, if this fraction reduces back to this, then you've done it correctly. Minus, and then do the same thing here. This quantity is the 5 and the n minus 1. So I need to multiply top and bottom by n plus 1 to get the common denominator. Once I have the common denominator, I can combine the two fractions into one. And then I'm going to simplify the top by distributing things and combining like terms and bringing it all together into one expression. I'm going to factor this to see if it can reduce anything on the bottom. This on the top factors into this, but it didn't really do anything for us. And so there's our final answer. You do not need to remultiply it out. You just leave it in that fashion. So just take your time when you do this and make sure you ask for help if you need it. Okay? The last one is complex fractions. Complex fractions is basically fractions inside of a fraction. Okay? And so what you want to do in this case is we're going to do something like this. We need to find the least common denominator for all the inside fractions. So here's an example of it. So I have all these inside fractions. There's a b, a d, a b, and a d down here. And so the least common denominator of all of these inside fractions is bd. We're going to multiply the numerator and the denominator by this LCD. So the top gets in parentheses, I'm going to times it by bd. The bottom gets in parentheses, I'm going to times that by bd. The reason why you multiply by the least common denominator is it will eliminate all of your fractions in there. So as I distribute this b times d, this denominator is going to reduce with that one, leaving only a and d left. This one multiplies with that. The d's reduce, leaving c and b. This times that, the b's reduce, leaving b and e. I'm sorry, d and e. And then this one is fb. So you see how the inside fractions are eliminated, and I'm left with this. At this point, we started to simplify, reduce, simplify, and see if we can do anything with that. And if we can, we do. If we can't, we don't. Okay, so let's look at an example of that. So this is one that's on your journal. On that one note that I wrote, here it is again. Anytime you have more than one term in a numerator and or denominator, always put it in parentheses. So It was so important I wrote it twice. Okay, so here's my problem right here. I look at the denominators of these inside fractions, and I notice that I can find a least common denominator. I have a 4 and then a squared. There's my least common denominator, so I'm going to multiply the numerator and the denominator by that, because literally what I'm doing is I'm multiplying by that divided by itself, which is just 1. So I'm just changing the form, I'm not changing its value. So when I distribute, things drop out. 4 times a reduces with this, leaving an a. 4 times that, the 4's reduce out, leaving an a squared. That times this, the a squareds drop out, leaving the 4 and that. And as I distribute that over to here, an a drops out, leaving a 4a and the quantity in the parentheses. You see how using the parentheses helps us with our work? It makes it a lot easier and cleaner. So always get used to putting in parentheses if you have more than one term in a fraction. Distribute and combine like terms on top. Distribute, combine like terms on the bottom. So as I did all that, I have this. Then factor everything and see if anything can reduce. So in the top here, we had a common factor of 2a, a plus 5. The bottom had a common factor of -4, which I can then take that out and then refactor the rest. And then I look at that thing, and the expressions over here, nothing reduces, but this 2 and the 4 can reduce. And so then this is my final answer over here. And sometimes you can put the negative on top or on the bottom. It doesn't matter, but I left it on the bottom here for you so you can see it. But there it is. There's no need to multiply anything out on that. Just leave it as it is, and you are done. So this is how I add, subtract, multiply, and divide rational expressions. Use the format of fractions if you get stuck or forget what you're doing, because that's all you're literally doing. And we'll do more examples together in class.